So your first step is to obviously copy these terms down. Just so you understand, we're not just looking for definitions today. I'm going to be talking about how we go about the process of soldering and how all these things come into play. So in addition to what these things are, you need to describe in that section how to do it, how to solder, how to select the proper soldering iron, what kind of iron should it be, and how should you actually use it. There is going to be a lab exam, and it's going to cover two main areas. We already had a lecture on the different parts, the capacitors, the resistors, the diodes, their symbols, and what each one does, remember? We're also going to have questions on that lab exam, going to have questions on that lab exam about how to solder. It took me several weeks of just trial and error to figure it out myself, and I got better over time. So I'm hoping that you'll be able to learn in a 45-minute lecture how to do this. You'll have about 15 minutes to practice on some small boards and wires there before we before we solder our boards tomorrow, okay? Some of you will ruin your boards tomorrow. Hopefully that won't be the case. If you're good at paying attention to detail, you have good control over your hands and doing detailed work, you'll probably do well with this. Typically the girls do better on this than the guys do. They're more patient, and they usually have better what we call fine motor skills. That means the ability to do little detailed things. If you're the person who dropped your the nuts that you were putting on the bolts when we put together that part, you dropped them like 5 times before you got them started on there, this is probably going to be a little more challenging for you. But if you take some of the things that I'm explaining today to heart and really try to follow my directions, I think you'll be pretty successful. It's kind of cool, and it is a useful skill. You'd be surprised how many times you might end up needing to do this. And there are some of you that may have soldered already. How many have already done some soldering? Okay, maybe in elementary school you had a teacher that was into stained glass. You did some soldering with that. Maybe your dad or mom or whoever is a plumber, and you've seen how solder can be used to hold 2 copper pipes together. Well, that's going to be different. It is still soldering, and we don't say the L. It's not soldering. It is still soldering, but it's a different set of skills and techniques all by itself. I don't even know a lot about how to do those others, okay? But I can tell you how to do this one. All right? So this week, today we learned the skills, and you get the rest of the information that you'll need for your lab exam. Tomorrow, then, you'll be going to your lab stations and begin actually soldering the parts that you put in. I'll call you guys up one at a time, and I'll look at your boards for any obvious mistakes before you get too far, and that'll be your install parts check. Then when you're done soldering, then you'll have a solder check, and then when you're done with that, you'll have a worksheet that involves actually using your metal detector to search for some metal. The final thing then on this quarter will be the lab exam, okay? Soldering iron, soldering guns. They come in all different shapes and sizes, and as I kind of already hinted towards, the different sizes depend on the use. Are we trying to heat up something very big, or is it something very small? The bigger the area that you're trying to heat up, the bigger the soldering device needs to be. Okay? A soldering gun is often found in a lot of your homes. You might have that in the garage in a little kit. Those are not the kind that we would typically use on small, little, detailed, delicate electronics like this. We know that heat is the enemy of some things. In particular, we already talked about one part. Which part was that? Which part is heat the enemy of? Which part did we talk about that has little teeny tiny delicate parts inside that can be easily damaged by too much heat? IC, there it is, okay? And so there would definitely be a disadvantage to using a bigger one. You know, imagine that you're trying to carve into something. You know, you're trying to carve into a little teeny tiny block of wood and you want to put your initials on it. You might use an X-Acto knife or a really sharp little instrument. You wouldn't get out an axe for that, That's going to be way too big and bulky and hard to control to carve your initials in a little block of wood. That's what using one of these would be like on one of these circuit boards. The end of that would put so much heat on such a large area it would destroy it, and you wouldn't be able to control where that heat goes. You guys probably already know that the soldering iron, the definition, if you want a definition of a soldering iron, is a device that melts solder to make a connection on the board. You can write that down, but you probably already knew that, right? Soldering iron is the device that melts solder to make the connection on the board. That's not going to be a test question, because that's just something that you should already know. But I will ask specific questions about what kind of soldering iron should you select and how should you use it. That's the stuff you want to listen for carefully today. So we want to use the iron that looks like a pencil. These are called pencil type soldering irons. And the end of this one, the iron has two pieces of metal and usually has a piece like this that's pretty big, like a finger, leaving a large area. It'll make contact with a large area of metal and heat it up. The end of these irons, they come down and they come to what we call a chisel point, like that. So they're going to be able to focus that heat in a much smaller area and control it. Okay? And these are not to scale. This is going to come to a much smaller area. This is much bigger on this one. When you go to buy your soldering iron, first of all, you want to make sure it is a pencil type. So you would add that to your definition, if you will, of the soldering iron. You want to use a pencil type. But how hot should it be? Well, they don't put on the soldering iron the temperature, typically. Instead, they put down the watts. So when I say how many watts something has, you guys might remember. What's the formula for watts?
Amps times volts.
You got it. Amps times volts. Now, all of those soldering devices I showed, whether it's a pencil, iron, or a gun, they all run off of the same outlet electricity. How many volts is that? How many volts in the outlet, guys? 120. Anywhere from 115 to 120. If I know that I have, for instance, this was the kind of question you got wrong on the test, so that's why I'm throwing it at you again. If I know that I have a 120 watt light bulb, can you tell me how many amps it's going to draw, it's going to use? You guys serious? 1. I'm saying what times 120 equals 120? Everybody? 1. So the answer would be 1 amp. Okay? And because everything in the house, for the most part, runs off of 120 volts, you know that if it's more watts, it's going to be more amps. How about if it's 60 watts? How many amps is it going to use? Huh? 0.5, half an amp. Okay? So this wattage business, whether it's a curling iron, a blow dryer, an air conditioning unit, a soldering iron, a stove, it goes on and on and on. If you know the watts, you know that the higher the watts, the greater the current, the greater the amps. If it uses more amps, it's doing more work typically. Okay? And so we don't know the temperature of each of the irons. I can tell you they're going to be around 400 degrees or so. But we do know that if it's got a higher wattage rating, it's going to get hotter. A 3600 watt blow dryer is going to produce more heat than, you know, a 1200 watt blow dryer. Same thing with curling irons and so forth. So the higher this is, the more heat you've got. This was the kind of math problem I gave you on the test that some of you didn't even try to do. That's what I was asking you. Watts equals amps times volts. All you had to do is tell me 120 times what equals 120. And you guys didn't even try, many of you. They were really simple math problems. We got a real math phobia in here. Okay. So, pencil type iron. Now, how much wattage do we want? Well, I'm going to give you a number. You can add this to your notes. 15 to 40 watts is a good place to start. You don't need to go above 40 watts. You could probably do just fine for this circuit with 15 watts. Our soldering irons are 30-watt irons. They get more than hot enough to get the job done. In fact, they get so hot that if you don't use them properly, you will destroy the board. Well, that's a good question. I could tell you 20 watts would be perfect. You can buy these same types of pencil irons. They're almost always in this range. So anytime you see an iron like this, they're almost always in that range. If you start looking at the bigger guns, like these are often 150 watts. So like 10 times as much heat as we need. Well, if you're going to have to heat up a bigger area, more copper, you're going to need a bigger iron. Okay? If you're heating up, like, let's say it's copper pipes, you're going to fuse together. You're going to put a coupler on there. You're going to fuse together two pieces of copper piping. That is a lot more area, a lot more metal to heat up than this little tiny sliver of copper on here. And if you were to try to use these, good luck. The heat would be carried away by the copper. You wouldn't accomplish anything. You need a lot more heat in that case. In fact, this might not even be enough. That's where you get out the blowtorch. Has anyone ever seen copper pipes put together with solder and a blowtorch? Whatever you got in your mouth, you need to spit out. Yes? You have? Okay. So some of you may have actually had a chance to do that. It's pretty cool, and it works quite well. But we use some different materials when we're putting pipes together versus when we're hooking a teeny tiny wire on a teeny tiny sliver of copper like we are on our circuit boards. So yeah, it is a big range, Dominique, but I gave you that range because pretty much all the pencil type irons, which will be okay, are going to be in that range. I would stay more towards the bottom of that because these are 30 and they're probably still too hot. Okay. So I'm going to take you through the process of soldering and the steps that are involved and give you some general advice here. We've selected the right kind of soldering iron. Okay. The next thing is you've got to know how to hold it and how to use it. Because of that tip, remember I said it has that little chisel tip? You want to hold it at a certain angle. You want to hold it like you would hold a pen or pencil. Okay? That sounds like a test question. Hold it like you would hold a pen or pencil. At what angle would you describe this?
45 degrees.
Yep, 45-degree angle. You want to hold it at a 45-degree angle, like you would a pen or pencil. The reason for that is, if you're looking at the circuit board from the side, okay? Remember, the circuit board has two sides. It has the component side and it has the solder side. When we're soldering, we want the solder side up. And the part, let's say it's a little resistor here. So here's my resistor, and the wires come through the board like that. You with me? We're looking at this from the side. And on top of this then is that piece of copper, the donut. The donut is that round piece of copper that has the wire coming through it. That's the wire coming through it. And we bent those over right now. They're bent over like that. Well, what you want to do is you want to get the iron on there. The reason you're holding at a 45-degree angle is because of the design of that tip. Because it's slanted like that already. It's got a chisel tip. If you put it at this angle and you put it on top of the little donut there, do you see how you're going to make a bigger contact area? You're going to heat up this entire area below it. If, however, you held it at, let's say, a 90-degree angle, like that, you're only going to heat up a small little point on the end. Does this make sense? So that's why we hold it at a 45-degree angle. Now, just because you hold it at a 45-degree angle does not guarantee you good results. The reason for that is a lot of people never developed beyond kindergarten stage of writing. Some of you don't hold your pencil the way you are supposed to. The truth is that every skill we learn, we go through different phases. We have a very beginning phase, kind of an intermediate phase, and then an advanced phase. It goes for using a computer mouse, throwing a ball. We all go through these phases. Has anyone ever worked with someone who's never used a computer before and tried to show them how to do something on a computer? Okay. Your dad never used a computer before?
No, he's like 7 years old.
Stop calling the teachers.
Okay, yeah, dude. Okay, so maybe you saw something like this with your dad. I saw this kind of thing with my grandma. It was pretty funny. So you say, okay, grandma, here's the mouse. You're like, woo, where's the mouse? She thought it was a little mouse. No, grandma, this thing right here, we're going to move this around. This is the mouse, right? Okay, grandma, when you move this, the little hand will move on the screen. And you show her how it's done, right? And so they go and they put their hand on it, and they go, whoo, it went off the screen. Whoo, it went off the screen that way, right? Anyone experience this? And you're like, grandma, you're not doing it right. Grandma's doing this. What is she doing wrong? What am I doing wrong? Why do I have no control over the mouse? It's not just her age. What would you tell me to do? What's the first thing you tell me to do different about how I'm moving the mouse?
Move it slower.
Put your hand down.
Put my hand down. Thank you, Dominique. Put my arm down, right? Now this looks like someone that knows what they're doing. Big difference. Beginner, advanced. You learn one little thing. They didn't know that. It's not because they're retarded or anything like that or just because they're older. They just didn't know that. You make the same mistakes. Believe me, I could make fun of you guys when we go to soldering because you're going to do some similar silly, stupid stuff. Let me give you an example with throwing. When we learn to throw, we go through different phases of development. I took a class called motor development. We study how you use your muscles and how you develop. You take a little kid, you show them, okay, we're going to throw this ball. Step number one, they use their whole arm and they throw their upper body like this, right? Then they get a little more advanced and they realize that it helps if they step with it. So they step with the same leg, like so. Okay? Then they get a little more advanced and they realize, I should turn the other leg, and they throw like this with the other side. More advanced, they realize how they should bring their elbow around and release once the elbow comes around and release with the wrist at the end. And they're now using all their joints properly. Well, we go through that same development with writing. Step number one for writing, since this applies directly to soldering. We go to kindergarten stage, pre-kindergarten, right? Teacher says, draw me a picture. And the kid goes, okay, I'll draw you a picture. And take the crayon in their fist like this. And they put their arm on the table. And I'm drawing clouds. And I'm drawing Ma. And I'm drawing Pa, right? And you can see what's happening. They're holding that crayon in their fist. And the motion's coming from the shoulder joint. Well, it's no surprise that everything looks like a big round squiggly line. You know, because it's all the same kind of motion. You're using your shoulder. You don't have a lot of control there. You graduate, first, second grade. Maybe now you've moved to not using the shoulder, but using the elbow. Maybe you've moved away from grabbing it like this to grabbing it like this, which some of you still do. And now I'm coloring, and you still got your tongue sticking out of the corner of your mouth, and you're coloring, but you're not staying in the lines. You haven't yet graduated to the more advanced stage. Some of you are still at this stage, using your elbow as the main motion. As you go from shoulder to fingertips, you get more and more precise control. You're going to have lousy handwriting. You're going to be a spaz soldering. You're not going to be able to knit. You're not going to be able to put little nuts on little bolts if you don't learn how to use the most precise part. We've got to get farther out here. Some of you are at the intermediate stage now. You're using your wrist. So you put your wrist on the table and you're using your wrist like this to write. And you're still gripping it in a fist. It may not look exactly like the kid did in kindergarten, like they're going to stab someone, but when you grip it back here, behind these knuckles, that is the same as grabbing it in a fist. Let me finish. This is not the proper way to hold a pen. Hopefully you all realize this is not how you're supposed to hold a pen or pencil. The most advanced ones, show me. Everyone hold your pencil up the way you think you should hold it to write. No, I'm not messing with you. There is a right way.
Is this right?
Point the end of the pencil at me so I can see how you're holding it. Okay, Alec has it right. Matt, I think, has it right. I can't see. Antonio does. Jerry does. Okay, some of you do it right, some of you not so much. See my triangle there? See my triangle? All sides should be equal. I didn't draw it perfect there, but all sides of the triangle should be equal. One finger goes here, thumb, and the side of the other finger goes there. This is called the dynamic tripod. This is the correct way to hold a pencil and the correct way to hold your soldering iron. First finger on top, thumb over here. This part of your finger on the other side. When you hold it like this, now when you move, that motion comes from your fingertips. You can be super precise. You can move it a millimeter at a time if you want to. Your wrist is on the table, just like grandma's wrist should be when she's using the mouse. And the motion can be very precise. You need to move more, you can move the wrist. A little less motion, more precise, you use the fingers. But at no time do you actually write using your shoulder or your elbow. That's going to be totally imprecise. Okay? That's the way you should have been taught. They don't teach this much anymore, and they let you guys do this kind of stuff. As soon as it goes past those knuckles, I'm not going to tell you right or wrong. I'm just going to tell you that this is the proper way to hold a pen or pencil. Okay? But if you go past those knuckles, now it's just like holding in your fist. You can't have finger motion if it's past these knuckles. Okay, so if, Dominique, you go in for an appendectomy, they're going to cut out your appendix, right? And you're laying on the table, and the surgeon's standing over you with their tongue sticking out of the corner of their mouth because they're ready to do some coloring, some cutting, and they have that scalpel, and it's in their fist like this, I'd crawl off that table as quick as you can because that cut is going to be pretty ugly, right? You want to see them hold the scalpel like they would a pencil. They're going to be drawing lines with it to cut very precisely. Okay, so hopefully we all understand now what I mean by hold it like you would hold a pencil, what the proper way to hold a pencil is. All right, so we're going to prepare the soldering iron. Step number 1. Clean the tip of the iron. This can all go under your definition for soldering iron. I don't care where you put it, but this is the how-to part. If the iron's been handled and it's got, please stop tossing your pencil. It's been handled and it's got a lot of finger oils on the end, that could affect the solder from working properly with it. So just using a little bit of steel wool to clean off the end is the good first step. Step number 2. What do you generally do when you're going to use an appliance?
Turn it on.
Yeah, plug it in would be a good idea. Okay, so that's your next step. You're going to plug it in. Excuse me. Thank you. So I'm plugging it in. Now, here's the most important thing I want you to know about soldering. This is highly technical, and you're going to really have to listen carefully to see if you can follow this. You ready? Everybody looking? Okay, here we go. Hot part. Cool part. One more time. Okay? Hot part. Cool part. Now, why do I have to say this to people? Because there are morons in 8th grade. Don't point at Dominique. Every year, somebody reaches out and grabs the hot part. And they say to me, I didn't know it was hot. I didn't know it was going to burn me. Hot part. Okay? Now, I have different stands around the room. One person in each station can use the little coiled one. That's my preferred stand. That's what's actually designed for that purpose. The others are my makeshift stands that I use clamp stands for. So you slide it in like that. Grab the plastic part to take it out. Don't grab that part. If you use the soldering iron on anything that it wasn't intended for, burning hair, burning plastic, burning the tabletop, you will be done. Okay, not just for practice, but for the rest of this. You can figure out, go get your own soldering iron. I bought these all myself, my own money. I don't have replacements for you. And what people do is they end up breaking them because they're careless. They do things like, oh, it's not getting hot enough, so I'm going to press harder. Pressing harder won't make it hotter. That's The number one mistake people make with this. They don't get it on the joint. Remember how I showed how to put the tip on there properly? They don't get it on there properly so they don't transfer heat. If just the tiny little tip of it's touching and not that whole surface, you're not going to get enough heat to melt the solder. The other two mistakes people make is they take the solder and they try to put the solder directly on the iron. I had somebody a couple years ago just insisted. They knew better than me. Oh, I heard your method, but that's not the way to do it. The way I do it is I just take the solder and I put it on the iron and then I put it on the connection. Just like this and that. That's not going to work. You'll see why here in a little bit. You do not put the solder directly on the tip of the iron for soldering. You do it one time at the beginning. That process is called tinning, and it's not even up there. Oh yeah, I guess it is right here. Tinning. You're going to tin the tip of the iron. Now I have to wait about 3-4 minutes for this to heat up. When you do your practice, make sure you let it heat up enough. It's just like when you're baking cookies, right? You got to let the oven preheat. When a little light comes on, then you put it in. Be patient. Let it reach that operating temperature. If you rush it too soon, you're not going to have good results. Yes.
Well, my brother was doesn't know how to use my mom's super duper oven. There's 2 start buttons on it, and it changes which one. So my brother's getting it going.
Okay, the solder. When you use the solder, guys, again, the mistake is people use too much. A lot of people are under the false impression that more is better. Okay, I have more solder, I'm going to get better results. Notice how close these connections are. Super close, and if you're not careful, all 4 of these that are supposed to be separate connections will all become one. And people are shocked that their circuit doesn't work. There's a reason they're separate connections. They need to stay that way. If you use too much, you'll end up with a mess. And you'll combine things that shouldn't be combined. You know, same thing is true like when you're trying to glue wood together. There's the right amount of glue. Too little, it's not going to be right. Too much, it's going to be weak as well. So you want to use the right amount of solder. I can tell you that to do our entire circuit, this is enough to do the entire circuit. Some of you will use that amount to do 3 connections. Look at how tiny they are. It takes a little teeny bit to do just 1 connection. So that's why this is more than enough to do your entire circuit board. So don't use too much. When I said tinning, again, the tinning, if you wanted to write that in your notes, is applying a thin coating of solder to the tip of the iron before you solder. Applying a thin coating of solder to the tip of the iron before you solder. It kind of pre-coats the iron so that solder won't just gather there too much. Applying a thin coat of solder to the iron before you begin soldering. And this is how much I'm going to use. You can see here. Boom. There's a little bit on that side, a little bit on that side, and that's it. It's tinned. You'll actually see a little buildup of the solder already on that tip. All I have to do is tap the iron and that'll come off. You should do that tapping over the metal plates of your stands. Okay? We don't want a glob of solder on the end. Here's another important rule about soldering. Solder goes to where it's hottest. The hottest thing we're working with is the iron. So if you take the iron and you put solder on the tip, that's where it wants to stay. You try to then drip it on here, it isn't going to stick. You'll end up with a glob just like these, and I can scrape those right off. Okay? Solder goes to whatever's hottest. So don't put it directly on the tip of the iron. The only time you do that is at the very beginning, when you tin the iron. That's what I just did, coating it with a little bit of solder. They call that tinning, by the way, because solder has tin in it. Yes?
Can you do that tinning one more time, Brandon?
Yeah, all I'm doing is just a little bit here, a little bit on the other side, just a touch, and then tap off the excess. Thank you for looking out for Brandon. The other safety precaution I forgot to mention, guys, you'll notice that the cord here, I want to keep that cord on the outside of my wrist. I don't want it on the inside in here, because as I'm working around, I could end up touching the cord. That cord can carry up to 15 amps. If I were to touch this and create a short circuit, 15 amps would then quickly flow through the metal part of this, and if you happen to be touching it, or this melts through, then bad things, okay? Keep that cord outside your wrist, like I'm showing here, on the outside of your wrist, so it's out of the work. You'll see some of the cords have been accidentally touched by the iron. And again, if you misuse the iron, you're going to be sitting out. And you can work on something else for the next week and figure out how to solder yours at home. Okay? All right, so we have tin or tinning, and that's applying that thin layer of solder to the tip of the iron before you solder. Let's look at the solder now. You're going to have to pick the proper kind of solder. Well, we know that we want to use what's called rosin core solder. So this is rosin core solder. Whenever you do electronics, it's rosin core solder is the type to use. The rosin inside, that's what you saw create the smoke. When I heated it up and it melted, the smoke that came off, that was from the rosin. The residue on here that looks kind of brownish like tree sap, that's the rosin. The rosin helps it flow and stick. Whenever you're doing electronics, it should be rosin core solder. I point that out to you because there are other kinds of solder that will look just the same, will melt with your soldering iron, but they're not rosin on the inside. If you're using solder designed for pipes, that's called acid core solder. Acid core solder is designed to actually eat into the copper pipe itself. So you got your two pipes there, and what you want to do is when you heat up that solder, the acid comes out of the center of that solder, and it makes little pits all the way around on the pipe. Little tiny pits by the acid. Then the solder will flow into those little nooks and crannies, those little holes, and it really makes a tighter bond to the pipe. So the idea is we make a stronger physical bond. We can afford to make little pits in that copper because it's thick. If you do that with this type of circuit board, it is way too thin and delicate. The acid will just eat away at big chunks of the copper. So again, do not use acid core solder, use rosin core only. I like to use this thinner stuff because it gives me more control. I don't use too much solder when I have the thinner one. When I have the thicker one, you tend to put too much on. If you look up close at the solder, you'll also see, well, it's got a little smudge or something on it. Let me flip it over. Oh. You'll also see that it says 60-40 right underneath that. It says 60-40. What that's saying is that 60% of that solder is made of lead and 40% is made of tin. What do we call a material that's made of two different metals?
Alloy?
An alloy. We talked about this before. Rosin core solder, an alloy of two metals. Yeah, you guys are catching on now. That was a pause for notes. Rosin core solder, an alloy of two metals with rosin to help it flow and stick. An alloy of two metals with rosin to help it flow and stick. That's going to be on the inside. It's hollow in the middle with that rosin in there. We don't want to use what kind? Acid core. Don't use the kind that has acid on the inside.
Is there other kinds of solder?
There may be. I don't know. Solder comes in different formulations, different amounts of tin versus lead. In fact, nowadays, most solder doesn't have any lead in it. Do you know why?
Poisonous metal.
It is a poisonous metal. They used to have lead in what product you'd find around the house? Paint. And paint would chip, and little babies would eat the paint chips, and it would cause brain damage. So exposure to lead is a bad thing. You don't want to ingest lead. So what they've done now is they've started to get rid of the lead solder, and a lot of the products are being made without lead. And that brings us to a little side story I'll share with you here real quick. Here's my board, here's the wire coming through, and then I have my little dome of solder and another one over here, my little dome of solder. And after you solder it, then you trim off the end, the wire there, and you just have little domes like that. That's the completed circuit, okay? Like resistors here on the other side. Well, what we're finding is happening now that they got rid of the lead in the solder, is little crystals are starting to form on those solder joints. They're growing whiskers. Like an old man, those little whiskers form. And this problem is going to be big in the future. I don't know if you guys remember when we turned to the year 2000, we had a big concern about computers failing. Do you know why?
People are crazy.
Because all the files saved on computers, we only used the last 2 of the year. So it was fine when it was 1976 or 1999 because we knew what year it was. But when it turned the year 2000, we didn't have this information. So we didn't know if it was the year 2000 or 1900. Okay? And you may say, well, gee, can you look at a calendar? Yeah, you can. But the computer doesn't know the difference. And what if it's your bank account and you're given interest? Should I give it to you for 100 years or 1 year? See the problem? Maybe your bank account will go to 0 because the computer's confused and it thinks it's the year 1900. Nowadays, when you save programs, files on your computer, it's always 4 digits. So we have all the digits. We know it's 2008. We don't think that it's 1908. But that was a big concern when it turned the year 2000. There was people running around like crazy trying to fix all the computers with new programming so that they had 4 digits and not 2 digits for the date. Yes?
Did anything actually happen?
There were minor problems. Most companies were able to address them. But yeah, I think there were some problems. So back to my whiskers. Okay? What's happening now is now that we got rid of the lead in the solder, the solder now is doing some weird things no one expected. It's growing these little whiskers. And eventually, what's going to happen? It's already happened. Some of them are connecting and creating what kind of circuit? Short circuit. Well, if you get a short circuit, the circuit fails. Now, what could happen? Well, you could get extreme heat and have fire damage. Or it could just be the circuit fails. And you're probably thinking, oh, whoop-de-doo, the circuit fails. So you have to go buy a new $10 CD player. What if that solder, without lead in it, is on a guidance system for a nuclear warhead, missile? And we're trying to send it up and test it over the ocean somewhere. Instead, it flies into Russia and kills 1 million people. Beginning of World War III. All because of taking the lead out to be more earth-friendly and these little whiskers growing.
But doesn't it take a
Well,
while
it's a part of the solder. You'd have to go in and redo all the solder joints. Or they'd have to come up with a way of treating these to keep that from happening. Even if they come up with a simple solution, spray some stuff on there or something like that, it still requires someone, billions of people, to go out and fix billions of pieces of electronics and identify which ones are likely to fail. Chris?
But doesn't it take like a while for those to grow?
Yeah, it does. And that's why we didn't anticipate that this was going to happen. So, you know, who knows? Sometimes some conditions might grow faster than others. You don't know. And all of a sudden it just fails on you.
So if you buy an iPod, it'll only be worth like $10 by the time it grows.
Yeah, probably. You're probably not far off there. Yes?
Yeah, that was one thing I was gonna say is that, you know, why would someone be using a computer just so old? So, you're using a computer
They didn't
that
tell
old.
them that they would be down.
Okay, that was back in the year 2000. Okay, and the computers then weren't old then. That was a problem that even the modern computers had at that time. All right, so, oops. Take a look at these 3 joints. Tell me which one you think is the correct one.
B.
B.
B. B is the way it should look. I can tell just by looking at A and C what they did wrong. You see, according to my directions for soldering, you put the iron on there, you hold it like you would a pencil at a 45-degree angle, and you heat up the entire joint. The joint means the donut here as well as the wire. If you heat up the entire joint, you're going to do it right. Then you bring the solder in over here, close, but not touching the tip of the iron. If you put it on the iron, it's just going to melt and give you a glob on the iron. You put it here. You let the donut melt the solder. If you do that, it will flow and just fill in around it and it'll look perfect, just like B. Okay? So this is the way we want it to look. On the other hand, if you look at A and C, this was probably heated up right here. Maybe they put solder and it hung off the bottom of the iron, and then when they put it down here, a little glob just fell off. I could probably go in and scrape that off with my finger. It isn't fused to the wire, and it certainly isn't fused here to the donut. There's no good connection there. It's just a separate little thing. It didn't even flow all the way around. If you heat up the donut and the wire, that's what we call the entire solder joint, then the solder will flow and fill in, just like pouring water into a glass. You don't have to do anything special. If you heat it up properly, it'll just fill in automatically. Down here, you can see they didn't heat up the wire properly, and they didn't heat up the donuts down here. I know that because you see how it curves underneath a little bit? That tells me that that didn't heat up properly. If you take a lump of butter and you put it in a frying pan and that pan is hot, that butter isn't going to be rounded and curved on the bottom. It's going to flatten out. It's going to be like that. See what I'm saying? So this shows me that this did not heat up properly here. Likewise, if you look at it at the top right here, it dips down right where the wire comes in. Well, that means that the wire didn't get heated up enough. So if the wire gets heated up enough, you get a nice smooth mound. Or it might be even a volcano shape like you see here. Okay? But you won't see it dip down by the wire. You won't see it dip under on the sides. How many understand what I just explained? Great. Okay, so that's a proper solder joint. Now what can sometimes happen as you do this, you get this perfect, right? And then you take the iron away and maybe the circuit gets bumped. Maybe the wire gets wiggled a little bit. And as that wire is wiggling, it's trying to cool. You know, that molten metal is trying to cool. And you end up with what's called a cold solder joint. A cold solder joint is one where the connection didn't cool properly. Maybe it wasn't heated right. Maybe it wasn't heated fully. Maybe the wire got wiggled and it didn't cool properly. And so you get an unreliable connection. It works some of the time and not some of the other times. I've had to fix electronics that had a cold solder joint. Manufactured electronics. You take it out and you hit every one of the connections with the soldering iron again. That's all you have to do to fix it. This is all lumpy and weird looking here. I heat it up. It goes into the proper shape on its own. I don't have to shape it or anything. If you heat it up properly, it'll take the right shape. It may look like the right shape, but be a dull color. Not a shiny silver, but a really dull silver color. If it looks like that, you have a cold solder joint. What do? Just reheat it and make sure this time the wire doesn't get bumped. You don't have to add more solder. Solder's fine, you just didn't let it cool properly. A cold solder joint is an unreliable connection. An unreliable connection that may be dull silver. An unreliable connection that may be dull silver caused by improper cooling, heating, or moving the wire. Caused by improper cooling, heating, or moving the wire. Caused by improper cooling, heating, or moving the wire. Now I'm going to have you practice here in just a little bit, just a little quick practice. One of the things I'm going to have you do is just solder two wires together. All you have to do is get them so that they overlap.
Whoa.
You want something to focus on. Come on,
The camera
focus on me.
got dizzy.
Yeah, thank you, Taylor.
Where am I?
So, get them to overlap. You can have a partner hold it here and here, an inch or so away from the ends because they do get hot. You heat it up, and you can do this on top of the metal plate that you have there for your stand. But if you do this properly and they're overlapping, and you put the right amount of solder on there, it's kind of hard to do by myself. You'll get a joint that is as strong as the wire. Sorry, there. And if I let it cool properly, that will be as strong as the wire, or stronger. The wire will likely break someplace else before it'll break there. Nice strong connection. Just to sever that connection, to desolder it, all you have to do is just reheat it and they'll just fall apart. Ruben?
Are we going to do this today?
Yes, in just a minute. Okay? The other thing I want you to do is take a wire, stick it through one of the holes, one of the good donuts on your circuit board, if there are any good ones left. Use this one here. Fold it back and solder a connection so you can see what that's like. Again, the process is, first, clean the tip. Next, plug it in. Wait 3 minutes, let it heat up. Cord on the outside of your wrist. Iron goes down. Hold it so the chisel tip, got too much solder on there. The chisel tip is on there. 1001, 1002, 1003. Bring the solder in nearby but not on the tip. And you take them away together. If you take away the iron first, it will cool around the solder and the solder will get stuck. Okay, so you take them away together. 3 seconds. That's how quick and easy it is to make a solder connection. To remove it, all you do, you can have your partner pull like this, hold the board and pull on it, and all you have to do is just heat that joint up there and it'll pull right out. Okay? Now that's the way to desolder these things. They're easy. But if you have a part, like a resistor stuck through there, and you realize, oops, I put the wrong resistor in, I need to take it out. Hopefully we won't make those kind of mistakes. But here's how you go about desoldering that kind of mistake. I'm going to put a wire through here and solder it real quick. There's 2 methods that we use for desoldering. One is the Desolder Vacuum. That's this little guy. Spring load it, syringe. Push it down, heat up the metal until it's liquid. Once it turns liquid, Mr. Slurpee. Okay? And when you push it back down, it kicks out the leftover stuff. Okay? It works okay, but it doesn't get everything off. The better approach, which you won't do today, but if we have to fix something, you would use this stuff. This is called desolder wick or desolder braid. And what I'd like you to have in your notes about that is, first thing you should do with this stuff is stretch it. I'm stretching to create little nooks and crannies in there to soak up the solder. I'm going to put that on top of the joint I want to desolder and put the iron on top of that. 1001, 1002, 1003. And it soaks up. You can see it turns a silver color there. It soaks up that solder like a sponge. Once it's full of solder, you just cut off that part and you have to throw it away. You can't reuse it like you can this guy. Okay? So the desolder braid, you stretch it, you put it on top, and you heat it up, and it takes the solder away. And desoldering is removing the solder so that you can remove or replace a part. If you didn't get all the definitions, I will show those to you now. Those are all the definitions and information that I gave you about each of those, the key points. I'm going to go ahead and number you guys off.